this particular problem, we have a cannonball of mass 4 kilogram that is fired horizontally from a height of 20 meters above ground level. It says to neglect any effect due to air resistance. There's A, B, C, D, E, and F. If you need to pause it, read it for yourself. Other than that, I'm just going to crack it. Part A asks you to find the initial mechanical energy of the cannonball. The initial mechanical energy is composed of two components, PE and KE. There's a PE because it is initially 20 meters off the ground. There's a KE because it is shot horizontally at a rate of 12 meters per second. So here I'm just going to plug and chug. Therefore, we can say the initial mechanical energy of the system is just contributed to PE plus KE. PE being mgh, KE being 1/2 mvi squared. HI being 20, VI being 12. So I'm just going to plug and chug. M is 4, G is positive 9.8 because this is a scalar quantity. Energy is a scalar quantity. So therefore, you just have to use positive 9.8. Height being from ground up, which is positive 20. And likewise, here VI is 12 because why it is written as V. It is the initial speed being 12 because speed is a scalar quantity. If you simplify all this stuff on your calculator work, 4 times 9.8 times 20 is 784. 1/2 times 4, which is 2, and then 2 times 12 squared, which is 144. 144 times 2 is just 288. And if you sum that up, you should get about 1,072 joules, and that is the answer to part A. Part B asks you to find the kinetic energy at point A. So in the diagram here, point A is 15 meters off the ground. So I'm just going to go initial, where it's being shot, final being point A. So here I'm just going to use conservation of mechanical energy because it says it neglect any effect due to air resistance. So I know mechanical energy must be conserved throughout the whole entire flight. I'm going to set up MEI equals MEF, MEF being at point A, MEI being from the very, very beginning of the problem. Here, I'm going to leave MEI the same on the left side because I already know the answer, which is 1,072. MEF on the right side, I'm going to break it down into PF plus KEF. Well, part B is asking for KE anyway, so I need to break it out or break MEF into its two components, which is PE plus KE. Here, the left side is the same, except PEF, I don't know what it is. What I can do is find it though, because PF at point A is 15 meters off the ground. So here, PEF is just mgh. I'm just going to plug and chug. MEI being 1,072 joules, which is from part A. M being 4. G being positive 9.8. Because once again, we're dealing with energy here, so please don't plug in a negative 9.8. HF here being 15 because it's measured from ground up. At point A, it is 15 meters above the ground as indicated in the diagram. KEF is left alone as is. You notice I didn't break it down into 1/2 mvef squared. KEF is left as KE because part B asked for KE. Other than that, simplify your work on the right side. 4 times 9.8 times 15, which is 588. And then to get KEF by itself, subtract both sides by 588, which I'm going to do. And then therefore KEF is simply 484 joules. And that's the answer to part B. Part C asks you to find what is the cannonball velocity, not speed, velocity at point A. I do want to point out that because it uses velocity, you have to have speed and a direction. So watch carefully. KEA is 1/2 mva squared. Well, I know what KEA is already from previous part. I just calculated the kinetic energy at point A is 484 joules. Here, I need to find VA. Well, mass is 4. I just plug that in. VA squared, I don't know. So 1/2 times 4 is just 2. And then to solve for VA squared, I divide both sides by 2. 484 divided by 2 is 242. And then to find VA, I have to square root both sides. Therefore, the square root of 242 is 15.56. And that is just a speed, though. It asks for velocity. So to find velocity, you need speed and a direction, right? So we already found the speed, which is half the work. So here in the diagram, I'm just going to label it to show you how to do this. What you just found is the vector, the magnitude of the vector here, which is 15.56. Well, Vx is 12 because it stays constant throughout the whole entire flight because Ax is 0. Well, here, theta is what I need. So I need to tell you the direction, which includes theta in this case. Well, I'm going to use cosine of theta because cosine of theta is adjacent over hypotenuse. Well, why cosine? Cosine because in this diagram, the 12 meters per second here represents the adjacent. What I just found was the hypotenuse, which is 15.56. So cosine of theta is adjacent over height. Therefore, cosine of theta is 12 over 15.6. To find theta, divide both sides by cosine, which makes it cosine to the negative 1. 12 divided by 15.6. If you punch that in your calculator, you get cosine inverse of 12 divided by 15.6 is 39.54 degrees. So here the proper way to say part C, the answer to part C is 15.56, which is the speed. And you have to provide the direction here being 39.54 degrees below the positive x-axis, or you can say 39.54 degrees southeast, because this vector here that I'm tracing back and forth with my cursor, the speed is 15.56, but this is a diagonal that is pointing southeast, right, and down. Okay. So therefore, the answer to part C is 15.56 meters per second, 39.54 degrees below the positive x-axis. All right. The other way to find the speed, though, using kinematics or just simply applying mathematics here, is just Pythagorean theorem. I can say VF squared equals VFX squared plus VFY squared. So here, I have VFX already. VFX is being 12 because VFX stays the same. You notice here the arrow that just came up here, VFY is pointing down because the cannonball is falling down. Well, I can just find VF, which is the hypotenuse, simply by applying Pythagorean theorem. Well, to do that, VFX, excuse me, VFX stays the same, which is 12. I want to square that. What I do need to find is VFY squared. Well, I need to find VFY. Well, to find VFY is pretty easy, right? All you have to use kinematics. VFY squared is equal to VIY squared plus 2g delta y. VI squared is going to be 0 because the cannonball is being shot horizontally, so there is no vertical component. So VFY squared simply reduces down to just 2g delta y. I know what g is, I know delta y. Using kinematics here, I need to properly plug in g being negative 9.8, delta y being the vertical displacement. It fell down, so it needs to be negative 5. Well, I know it fell down 5 because the initial height is 20. The height at point A is 15, so which indicates that it has only fallen 5 meters downward. Hence the negative sign for downward and 5 meters for the distance. So if you simplify this in your calculator, 2 times negative 9.8 times negative 5 will give you a positive value, which is 98. Here, I want to keep VFY squared as is. I will not square root it because I need VFY squared anyways. So therefore, I'm just going to carry my work down. To get VF by itself, I need to radical both sides, but 12 squared is 144. VFY squared is 98. So and then I'm going to square root that. So 144 plus 98 is 242. Square root of 242 is 15.56, which, as you can see, it is the same answer up here. So the speed is the same, regardless of which method you utilizes. So it's 15.56. And then to find the angle, the direction, you would need to use the same skills that I used in the first part of part C. All right, other than that, that is how you do part C. Part D asks, what is the cannonball speed at point B? So here, if it asks for speed, I don't need direction, so which makes things a little easier. Once again, the mechanical energy in the system stays the same throughout the whole entire flight, right? Because it says neglect any effect due to air resistance. So here I'm going to set up MEI equals MEF, MEF being point B because part D now is at point B, MEI being from the very, very beginning of the problem. So I'm just going to break this down. MEI stays the same because I know the answer for this already, which is 1072. MEF here at the point B. What I can do is cross out PF because PF is 0. At point B, the height is so small that H is 0. So therefore, the only energy left is really contributed mostly to KEF. So I'm just going to substitute in MEI for 1072. KEF can be broken into 1/2 MVF squared, M being 4, VF squared is right there. And then here, I can just simplify my work. 1/2 times 4 is 2. But then to get VF squared by itself, I need to divide both sides by 2. So 1072 divided by 2 will give you 536. This is VF squared. So to get VF by itself, you square both sides. So the square root of 536 will give you 23.15 meters per second. And because it asks for speed, I don't need to provide a direction. The other way, excuse me. The other way to do it is also, once again, just to break into a right triangle. Here, the arrow that just came up represents my VF. Well, my VF has components. It has a VFX, which is 12, because VX doesn't change. VFY, I don't know what that is. What I can do, though, is go ahead and find VFY, and using the same skill that I did here with part C. Okay. Well, I can find VFY, simply use kinematics. So here I'm just going to carry down my work. VF square equals VFX square. VFX being 12, that's square right there. VFY square, I don't know, so I can find it though. I can find it once again by utilizing kinematics. Here I left out VIY square because VIY square is 0 because it's being shot horizontally. So therefore VFY square is just 2G delta Y. G once again kinematics being negative 9.8 because it is accelerating downward, which is negative. And delta Y is negative 20 because at point B it has fallen the entire distance of 20. So, and it's negative because delta Y is a displacement, which is a vector. So the value is negative 20. So a negative times a negative makes a positive. So if you do 2 times 9.8 times 20, you get 392. Therefore, VFY square is 392. Once again, if you heard me earlier, I will not square root this. I need VFY because this is VFY that I'm circling. Therefore, I'm just going to carry my work down. VF is going to equal to the square root because this is VFY. Excuse me, this is VF square here. So to get VF by itself, you need to square root both sides. So the square root of 144 plus 392, which is the same as the square root of 536. The square root of 536 is 23.15 meters per second, which is the same answer as I got over here on the left side. Okay, so this is just another way to do it. All right, let's do E and F before I cough my lungs out. Part E asks you what is the net work done on the cannonball during the whole entire flight. Net work is simply net force times displacement. The only force acting on the cannonball once it leaves the cannon is the force due to the force due to gravity. The force due to gravity can be expanded to mg because Fg is just mg. Delta Y here, okay, it's given. So therefore I can substitute m for 4, g for negative 9.8, and then delta Y being negative 20. So if you simplify all that stuff in your calculator, you get 784 joules. And once again, work is a scalar quantity. It cannot be negative here. There's no friction involved here. So the answer to part E is 784 joules. Now, if you wanted to, you could use the work kinetic energy theorem. The work kinetic energy theorem is just the net work is equal to change in kinetic energy. Well, here, net work is what I'm trying to find. I can break up Kf minus Ki. Well, Kf is just 1/2 mvf squared minus 1/2 mvi squared. Well, I know everything already, all right? Here I can factor out the 1/2 and the m because both terms. You don't have to. I'm just going to. You don't have to. You can just plug and chug. So here, I know m, I know vf, I know vi. Vi is 12. Vf being, I think it's like 23 something. Yeah, 23.15. So here, I carry on the 1/2. The mass is 4. Vf is the hypotenuse, which is 23.15 square, minus Vix. Vi initially is just in the x direction, which is 12. And then we're going to square that. So if you do that correctly on your calculator, you should get the same answer of 784, which is what I have here on the left side. All right, on that, let's crack out part F. Part F asks you to find the total kinetic, the total time of flight. It's getting late. The total time of flight. So here, I'm just going to use kinematics. Delta Y equals VIYT plus 1/2 GT squared. VIY being 0 because it's being launched horizontally. Delta Y here is negative 20 because it's fallen down 20 meters, so the negative sign is vital. 1/2 gets carried down. The acceleration due to gravity is negative 9.8. T squared is what I'm trying to find. So therefore, to get t squared by itself, you can just multiply both sides by 2, divide both sides by 9.8. So 2 times 20 is 40, and then 9.8 is going to carry down. The negative signs will cancel out because that's a negative sign on the left side. There's a negative sign on the right side. That will make it positive. So it would be 40 divided by 9.8, which is t squared. But to get t by itself, you square root. So roughly speaking, 40 divided by 10 is 4. The square root of 4 would be about 2. So that is your answer for part F. All right. Other than that, stay nerdy. I'm sorry for my coughing. Good luck.